The US F-47 is too fast for fighter jet. Physics to explain. The Air Force just pulled off something extraordinary. While everyone was watching fifth-generation fighters patrol the skies, Boeing was quietly building something far more radical in total secrecy. The F-47 has been flying since 2020, and most of the world had no idea it even existed. This is not just another fighter jet. It is a sixth-generation aircraft designed to fly faster, longer, and harder than physics was supposed to allow, while remaining combat-ready the entire time. This jet is not impressive because it can reach high speed for a few seconds. It is impressive because it is designed to live there. Sustained supersonic flight, extreme thermal loads, and acceleration profiles that should destroy stealth coatings and airframes have all been treated as unsolvable trade-offs for decades. The F-47 ignores those trade-offs completely. China knows about it, Russia knows about it, and now you are about to understand why speed, not stealth alone, is what truly makes this aircraft different from anything that came before it. The story begins with a hard truth aerospace engineers have accepted for over 40 years. Speed breaks airplanes. The faster a fighter jet flies, the hotter it gets. At Mach 2, the skin temperature of an aircraft can exceed 250 degrees Celsius. That heat warps structures, degrades composites, and destroys radar-absorbing materials. This is why stealth aircraft historically sacrificed speed. The F-117 was slow. The B-2 was slow. Even the F-22, the fastest stealth fighter ever built, pays a heavy maintenance price every time it pushes beyond sustained supersonic flight. For decades, engineers said you could have speed or stealth, but not both for long. The physics seemed absolute. Friction heating, shock waves, material fatigue, and airflow instability all stacked against the idea of a stealth jet that could remain fast for extended periods. The F-47 was designed specifically to attack that assumption. What changed was not one breakthrough, but a system-level rethink of speed itself. The F-22 introduced supercruise, the ability to fly supersonic without afterburners. It was revolutionary but limited. Supercruise worked best in narrow flight regimes. Pushing the aircraft too hard still caused heat buildup, coating degradation, and structural stress that shortened service life. The F-47 was built to go further, not just faster, but faster for longer, and faster without falling apart. President Trump confirmed the F-47 exceeds Mach 2. That number alone does not sound impressive at first. We have had Mach 2 fighters before. The F-15 did it, the F-22 did it, but those jets treated Mach 2 like a red line. The F-47 treats it like a working speed. This is where the physics break happens. When a jet stays at Mach speed, things get ugly fast. Air compresses, heat builds up, and stealth starts falling apart. Coatings crack, seams expand, radar signature grows the say nazabal. Aircraft gets hotter, louder, and easier to spot. That is why stealth jets usually avoid staying fast unless they have no choice. The F-47 flips that logic. Instead of trying to protect stealth from heat, Boeing designed materials that actually handle heat better. The stealth is built into the airframe itself, not painted on afterward. No fragile layers, no constant repairs. Heat was part of the plan from day one. Of course, heat still has to go somewhere, so the F-47 actively moves it. Cooling channels run inside the airframe, pulling heat away from the hottest areas and spreading it out in controlled zones. Think circulation, not insulation. The result is an aircraft that can stay fast without glowing like a target. Speed also punishes control surfaces. At high Mach, airflow is unforgiving, and small mistakes turn violent. Older fighters brute force their way through it. The F-47 does not. Its flight controls predict airflow changes and adjust before problems start. The jet stays stable because it sees trouble coming. Acceleration is where this really shows. Most fighters can sprint, but only briefly. Afterburners burn fuel, spike heat, and kill range. The F-47's adaptive engines shift modes instantly. Efficient when cruising, aggressive when accelerating. No huge heat spikes, no massive fuel penalty. That makes speed usable, not something you save for emergencies. And in combat, that matters more than raw top speed. Speed is about time, time to strike, time to reposition, time to escape missile zones. The F-47 can move in, through, and out of danger faster than anything before it, and do it again and again. That is something current Chinese fighters still struggle with. Their engines run hot. Their stealth degrades. Their designs look impressive, but they cannot live at speed. While others focused on appearances, American engineers focused on the physics. Speed also changes survivability. Missiles rely on prediction. The faster and less predictable the aircraft, the harder it is to generate a firing solution. Combined with reduced infrared and electronic emissions, speed becomes a defensive weapon. The F-47 does not just avoid detection, it compresses the enemy decision timeline until responses become ineffective. This is where the F-47 stops behaving like a traditional fighter and starts behaving like a system. High speed allows it to reposition drone assets rapidly. Collaborative combat aircraft can be launched, recalled, and redeployed at tempos previous fighters could not support. The manned aircraft acts as the high-speed command node, reshaping the battlefield faster than adversaries can react. And the most important part is this: none of this required sacrificing range. Historically, speed meant short legs. Fast jets burned fuel aggressively. The F-47 does not. Adaptive engines, efficient cruise modes, and optimized aerodynamics allow sustained high-speed flight without collapsing combat radius. This is why the Air Force keeps mentioning numbers above 1,000 nautical miles. Speed and range are no longer opposites. Before we continue, take a second to like this video and subscribe. Over 98% of viewers watch without subscribing. It costs you nothing, and it helps us bring more breakdowns like this to you. The F-47 proves something engineers once dismissed as impossible. Speed does not have to be a liability. When treated as a system-wide design goal, it becomes an advantage that multiplies everything else the aircraft does. And we are only getting started. Speed also reshapes how air combat unfolds before a shot is ever fired. In older doctrines, fighters relied on positioning and numbers. Whoever had more aircraft in the right place at the right time usually won. Speed mattered, but only in short bursts. Today, speed determines who controls the timeline of the entire fight. The F-47 is built around this idea. When a threat emerges, the aircraft does not slowly maneuver into position. It compresses distance at a pace that overwhelms enemy command systems. Radar operators may detect something fleeting, but by the time they classify it, the F-47 is already somewhere else. Engagement windows shrink from minutes to seconds. Human decision loops simply cannot keep up. This is especially devastating to modern air defense networks. Integrated air defense systems rely on layered detection, tracking, and engagement. Each layer hands information to the next. Speed breaks that chain. A fast aircraft forces radars to update more frequently, processors to work harder, and missile batteries to reposition rapidly. Every delay compounds. The F-47 exploits this by sustaining high speed through defended zones rather than creeping through them. And because it can sustain that speed, it does not have to choose between penetration and escape. This is where earlier fighters struggled. The F-22 could sprint into danger and sprint back out, but sustained operations near its speed envelope, accelerated wear, and limited mission planning. The F-47 does not treat high speed as an emergency mode. It treats it as standard operating behavior. That changes mission design entirely. Instead of planning routes around threat zones, planners can plan through them. Instead of waiting for perfect timing, pilots can force timing onto the enemy. Speed becomes a form of initiative, not just performance. The engines make this possible. Adaptive cycle engines do more than switch between cruise and combat. They regulate heat flow, airflow stability, and pressure distribution throughout the engine core. At high speeds, traditional engines suffer efficiency losses and thermal spikes. The F-47's engines actively reshape their internal airflow to maintain stable combustion while limiting heat transfer to the airframe. This is why sustained Mach flight no longer destroys the aircraft from the inside out. It also explains why the engines generate enormous electrical power. Speed creates energy, and the F-47 is designed to harvest it. Electrical systems benefit directly from high-speed airflow and engine efficiency. This power feeds sensors, cooling systems, electronic warfare, and future weapons that depend on sustained energy availability. Speed is not isolated, it supports everything else. Acceleration also plays a crucial role in missile defense. Most air-to-air missiles rely on predicted intercept paths. They assume the target will follow certain performance limits. When an aircraft can accelerate faster than expected, change vector rapidly at high speed, and maintain that speed longer than predicted, missile solutions degrade quickly. The F-47's ability to sustain acceleration without afterburner dependency reduces its infrared signature during evasive maneuvers. That alone increases survivability. Combined with speed, it becomes extremely difficult to trap. This advantage compounds when paired with autonomous drones. Collaborative combat aircraft can be positioned aggressively because the F-47 can reach them quickly. If a drone encounters resistance or takes damage, the manned aircraft can reposition at speed to reassign tasks or extract information. Speed keeps the command node relevant across the entire battlespace. Without speed, the concept collapses. China's emerging fighter designs reveal this gap clearly. Their airframes emphasize stealth shaping and internal weapons bays, but engine performance and thermal management remain limiting factors. Sustained high-speed flight creates heat signatures their materials cannot manage effectively. Their fighters may look advanced, but physics still controls them. American engineers chose to confront physics directly. This did not happen overnight. The Secret X plane, testing that began in 2019, focused heavily on airflow behavior at sustained high Mach numbers. Test aircraft logged hundreds of hours pushing thermal limits, control responsiveness, and engine adaptability. Data from those flights informed structural reinforcements, cooling layouts, and engine control logic long before production began. By the time the F-47 entered manufacturing, speed was no longer an experiment. It was proven. This explains the program's unusually rapid timeline. Digital engineering allowed Boeing to simulate stress, heat, and airflow interactions at speeds previous programs could only test late in development. Problems were solved before metal was cut. That is why production could begin so quickly after contract award. Speed was not added later. It was foundational. And this leads to a subtle but critical point. The F-47 is not designed to chase enemy fighters in classic dogfights. Speed here is about dominance, not pursuit. It allows the aircraft to choose when to engage and when to disengage without consequence. Enemy pilots will rarely see it, and when they do, it will already be moving too fast to react to. In the Pacific Theater, this matters more than anywhere else. Distances are vast. Bases are vulnerable. Tankers are exposed. A fighter that can fly faster for longer reduces reliance on forward basing and vulnerable support assets. The F-47 can launch from safer distances, cross contested zones rapidly, and return without lingering. This denies adversaries opportunities. Chinese strategy relies on forcing American aircraft to operate within missile range. Speed pushes that range outward. Every knot gained reduces exposure. Every minute saved lowers risk. The Air Force understands this. That is why speed was treated as survivability, not luxury. Even logistics benefit. An aircraft that spends less time transiting is an aircraft that completes more missions per day. Faster turnaround, lower exposure, higher sortie rates. When speed is sustainable, it improves readiness rather than degrading it. This is why availability rates are expected to exceed those of the F-22. Speed normally increases maintenance. The F-47 reverses that relationship. By designing materials, cooling, and structures around high-speed flight, wear becomes predictable and manageable. Crews are no longer fighting physics after every mission. The result is a fighter that flies hard without breaking itself. All of this reshapes air superiority doctrine. The F-47 is not merely faster than its predecessors. It exists in a different performance regime, one where speed is continuous, controllable, and integrated into every system on board. That is what breaks the rules. Physics still applies, but the constraints we thought were fixed turned out to be negotiable. The Air Force plans to field 185 of these aircraft. On paper, that seems modest. In practice, each one represents a high-speed command platform capable of reshaping airspace faster than any opponent can respond. Paired with over 1,000 autonomous drones, the effective force becomes overwhelming, and speed is what allows that force to function as a single organism rather than scattered assets. By the time adversaries' field counters, the F-47 will have already moved the goalposts again. It's built to adapt philosophy and ensures engines, cooling, and control systems will continue evolving. Speed margins today become survivability margins tomorrow. This is not an incremental upgrade, it is a declaration that the United States is no longer content with matching adversaries. It intends to outrun them, outthink them, and outpace them at the most fundamental level. The F-47 does not simply fly faster than expected, it redefines how fast a stealth aircraft can live, operate, and dominate. And that is why this jet breaks every rule fighter jet physics was supposed to enforce. If this video helped you understand just how radical the F-47 really is, make sure to hit that like button and subscribe. Thanks for watching, and we will see you in the next one.